Hey, yeah, technical issues. No, you're not. You're not the one running Nate. I'm the one running Nate. It's been an eventful morning already, and it's 9 a.m. So let's see what the day brings to us today. But yeah, you're not late. I am. I need to figure out the whole screen share. I already pushed it back 15 minutes because life. But yeah, hopefully now we're good. Cool. Hey, I'm doing great. How about you? Yeah, I am on finally. I'm sorry guys. It was tough. Oh, hey, it was tough. All right, so this morning I want to do the implement parameter security module. Yeah, there's two more of this. So if I hadn't done this one, there would be more. Nice. Azure is awesome. It's I would say that is my favorite. I think the tool itself is great. The user interface is even better. It's ready made for everyone as opposed to everything else, which is made for developers only. So, yeah. All right, let's learn about parameter security. All right, think of security in layers. Whatever. I'm not gonna go over this. I'm not gonna read the same thing that you can read yourself. So basically, parameter security is like if you think of your security as an onion, right? You have the outer skin, and you protect like everything more and more on the inside. You basically protect your outside and then more and more into the inside, and the idea is like prevent somebody from coming in, and that's why you're talking about firewalls and DDoS protection and firewalls. So all that stuff. All right, can I suggest you want to rather do practical than study for certs? Yeah. I hate studying for certifications, and that's the only reason why these streams are here. It is such a pain to study for certifications, and I would rather do things rather than study for the certifications. I posted a challenge recently on Twitter. I'm gonna do it. I like it. I like the idea of it. I follow these. 1 second. I follow these scam baiter people like Kitboga and Scammer Payback and Trilogy Media and whatever. And these people basically they take those technical scams and they bait people to stay on the phone with them for hours. And so I was thinking, how do I create one of these virtual machines for myself? And since I can't afford to keep a virtual machine like this up 24/7, I want to do like infrastructure as code to define and deploy and destroy that virtual machine. And so my challenge to you, if you want a challenge, build that. Build that and try it. If you want another one that has if you want another place that has good content for cloud, is learn to cloud that guide. And let me see if I can put it in the comments. All right, so this link here, and No, not the GitHub. Let's get started. And here you will have like a different, there you go, different phases. And at the end, they have projects for you. So you can look at that, right? Here, projects. So, all right, cool. And yeah, like Boris just said, MS Learning also has hands-on at the end. All right, cool. All right, let's go back. Perimeter security. So basically, how to protect an attacker from coming in, right? That's basically what that is. Getting from the inside to your network. All right. See, okay, I like that. So basically, there's like different layers. That's like the onion that I was talking about, in terms of access to physical security, which is preventing access to your resources, physical resources, right? If you are if you have physical access to a server, you have root access to that server, type of thing. So that's why you have security. That's why you probably can't just walk into an Azure data center and do whatever you want. Probably very well guarded. I wouldn't be surprised if there was people with weapons there guarding the buildings. Identity and access. So that's the second layer where you prevent certain accounts from coming in, especially for your like public facing stuff. That's how you control access. Then perimeter, that's your firewalls and all that stuff. Network, you still have firewalls inside your network, but then in this case, you have some approaches like segmenting your network and making sure that only the resources that can talk to each other type of thing. Then that's compute. That's basically your antivirus, right? That's you secure your machine with the antivirus and firewall also at the compute level, and then you secure your application, your code, and all that stuff, and then you secure your data, right? So yeah, micro segmentation. Yeah, that's what I was talking about. Sorry, 1 second. Yeah, so like you create secure zones in your data center in your Azure and your Azure deployments to allow to isolate workloads and protect them individually. A best practice recommendation is to adopt zero trust strategy based on user device and application identity. In contrast to network access controls that are based on elements such as source and destination IP address protocols and port numbers, zero trust enforces and validates access control at access time, right? So what this means is you're not you evaluate if somebody should have access every time they ask for access. Granting access at access time avoids the need to play a prediction game for an entire deployment, networks or net. Only the destination resource needs to be provide the necessary access control. All right, so you have Azure Network Security Group, NSGs, for layer 3 and 4 to access control between Azure virtual networks and their subnets. I never know these layers, right? OSI model. I think that's what this is. Okay, cool. 3 and 4, network and transport. Right, so the network is the path, transport is the protocols. So we're really starting at yeah. So in Azure, you're basically looking at layer 3 up, right? In terms of security, so layer 3 and 4, virtual networks, subnets, and internet. you know what? Just gonna put this link in the chat so you can look at it more in depth. This is just the first link on Google. Nothing that I sponsor or whatever. First link in Google. Okay. Application security group define fine-grained network security policies based on workloads, centralized on application instead of explicit IPs, right? So basically what this means is now instead of being like, hey, I'm going to allow this IP address, I'm going to allow this whatever, you say, I'm going to allow this application, right? So you don't have to worry about ports. You don't have to worry about that. Like, I mean, it's still the same thing, right? Application security groups is basically the same thing as network security groups. The only difference is that you have some definitions of an application, and it basically applies all this together as opposed to individual ports, individual everything, right? Web application firewall. So basically, we're now at firewall level. Yeah. So it's more advanced. So you would do things like packet sniffing, make sure that there's no application layer. We're like 7, right? No, so when you get to a firewall, you have smarter detection. So you can be like, hey, I noticed a malware just got downloaded on my network, right? And you have better control over the whole thing. And LAPS, local admin password solution. A third party. I thought you said it's a third party. So basically, what LAPS is a tool that allows you to rotate your passwords on your servers on a regular basis, and you basically don't know the password until you need to get it because it's this is distracting because it's regularly changing. Okay. All right. Azure networking components. Okay. Supports dedicated one. Okay. The following section defines key terminology. Azure networking. Azure virtual networks are key components of Azure services. VNets. They securely connect resources to each other. And yeah, a VNet is a representation of your own network in the cloud. And it's a logical isolation of the Azure cloud network dedicated to your subscription. You can connect VNets to your on-premise network with Virtual One. So Azure supports dedicated one link connectivity. Wow, this is a tough morning. To your on-premise network and Azure Virtual Network with ExpressRoute. Yes. The link between Azure and your site uses a dedicated connection that does not go over the public internet. If your Azure application is running in multiple data centers, you can use Azure Traffic Manager to route requests from users intelligently across instances of the application. Sorry, I have an ear that's like stuck. Yeah, I don't know if it's fixed. All right, so virtual networks, it's basically a network, but virtual, right? Oh, not what I wanted to do. Oh, you know what? Actually, I should do that. Cool. So you can see. All right. All right, so enables for multiple types of resources, virtual machines, security communicate with each other on the internet and on-premise networks. A virtual network is scoped to a single Azure region. Right, that's something that we have to remember. A virtual network is only in one region. If you want a virtual network in multiple regions, you will have to take two virtual networks and peer them together or connect them in some way. through either, you could also do a VPN between networks and connect them in some way so that they talk to each other in different regions. Networks are made up of subnets. A subnet is a range of IP addresses within your virtual network. So, did they go over this? Okay. Maybe they don't go over this, so let's go over this. All right. Is that the thing? Where's the thing? Oh, there we go. Is that the thing? Oh, there we go. That's what I'm looking for. All right, so here you have blocks. That's a CIDR, and you can define how many IP addresses you have in your environment, right? CIDR range. So here, the higher the number, the less IP addresses you have. You can't do anything less than 29 in Azure. And the reason for that is because Azure requires 5 IP addresses. Right? Any subnet you do, Azure will have 5 IP addresses. So something to keep in mind when doing networking in Azure. So 29, so that gives you 3. So every of these numbers, the amount of IP addresses available, remove 5, and that's the number of addresses you can actually have in your network. So 16, you want to have 11. Here you have 17, and 59, and 125, and you can do the math for the rest yourself. Yeah, so it's defined. You define the block as CIDR address format right here. Okay, and CIDR. I should put that in here. Right, here's the link where I found this thing. All right. Okay, so each virtual network is isolated from other virtual networks unless you peer them, but they're logically separate until you connect them. For each virtual network, you can specify a custom private IP address space using public and private IP addresses. Public IP addresses you can use? Okay. Azure assigns resources in the virtual network, a private IP address from the address space you assign, CIDR range that we were talking about earlier. You can segment the virtual network into one or more subnets, so you can split it up however you want. Azure provided name resolution, or you can either have the Azure provided DNS, or you can also have your own DNS servers on your network. Public IP addresses, never mind. I thought you can use any address in whatever range, even like what outside of 10 and 198, whatever 168, 198. I don't remember. All right, IP addresses. You can have all these applications have a unique IP. It allows them to communicate with each other. That's Virtual Network 101. There's 2 types of IP addresses. Private, which is allocated to the machine within the range of your virtual network that is connected to. And you have public, which allows Azure to communicate with external clients. And they're assigned directly to the virtual network adapter. So you can't make a public IP for a network. You can give a network a public IP, but you can't give it a public IP range and have it public, right? It's dynamically assigned when you create the machine, and it's assigned to the virtual network adapter. of the VM or the load balancer. Yeah, and you can also add it to Azure only virtual networks. All IP blocks in the virtual network will be writable only within the customer's network. Well, I hope everything is good. I hope everything's good. Okay, virtual network packets through high-speed Azure backplane. Okay. Subnet, it's a division of your network. Network adapter, it's basically a network card on your virtual machine or load balancer or whatever you use. DDoS, distributed denial of service. Is there an image? Okay, let's look for an image of DDoS. Basically, DDoS, in case you don't know, the idea is you have an attacker and you have, it's more like this actually. So basically you have an attacker that controls their own machine, and then they control other machines through malware on other people's machines. And when they have enough machines, they can say, hey, everyone, let's just look at this website now. So websites aren't made to handle a billion requests, right? If the whole world started to look at a just like random website, right? This website would crash. It would just be like, hey, the server can't handle the loads. There's like billions of requests, and it will just be like, I can't serve everybody, and your website will crash. DDoS. So that's what happens. But there's a way to prevent that, and smart protection in Azure allows Azure services to be like, hey, I have way more requests than I think I should get. So we're gonna just turn those connections off. All right. Okay, so best practice 1, ensure the security is a priority throughout the entire lifecycle of an application, from design and implementation to deployment and operations. Application might have bugs that allow a relatively low volume of requests to use a lot of resources, resulting in a service outage. So if you're like, hey, this request uses like 10% of my CPU, and if I have more than 10 users submitting the same request at the same time, my service will not handle that, right? So there's a few things you can do to stop DDoS attacks in that sense. Is scalability. So make sure that when you have too many requests, you scale to accommodate all the requests. So this way, your DDoS attack is unsuccessful, right? So if you have 1,000 computers and you scale to 1,001 computers, that's plenty to stop an attack, because it's like, yeah, you want the data, have at it. Not a great solution, because if it is an attack, you're just wasting money for nothing. Availability, you can also say, hey, this is only available between this time and this time, right? So you can be like, hey, shut down, you're asking for this now, it's not going to work. Resiliency, to the ability of a system to recover from failures and to continue to function. Yeah, so if your server crashes, can it get back up without extremely large amount of work, right? So if you were attacked and you did crash from a DDoS, can you recover from that attack? Management, operation processes that keep a system running in production, and security, protecting applications from data and data from threats. So you should know how typical traffic volumes, I'm making up words. You should know typical traffic volumes, the connectivity model between the application and other applications, and the service endpoints that are exposed to the public internet. So you should be aware of all this, right? So they're saying, like, so you can, as a human, know. Helping ensure that an application is resilient enough to handle DDoS, or denial of service, targeted at the application itself, is the most important. Azure security and privacy features are built into the Azure platform, beginning with the Microsoft Microsoft Security Development Lifecycle, SDL. The SDL addresses security at every development phase and assures that Azure is continually updated to make it even more secure. We will look at SDL later in this course. Best practice 2. Design your application to scale horizontally to meet the demands of an amplified load, specifically in the event of DDoS. If your application depends on a single instance of a service, it creates a single point of failure, right? A single point of failure, bad. Multiple point of failure, better. 0 point of failure, perfect. For Azure App Services, select an app service plan that offers multiple instances. Let's look. All right. All right, these are the tiers, right? They're the tiers. They're not like the individual instance. There's more, right? So where do we auto scale, right? So if you want something for production, you will want something that can auto scale to accommodate the demand elastically. Yep. Yeah, and dedicated compute is also good. The dedicated is good. Isolated is better, because it means that basically everything you have is yours and yours only. So if somebody else is getting a DDoS, you don't get affected by it. Okay, instance. Okay, and then you have the prices, right? So your pay as you go. You're looking at starting at 10 cents an hour, 20 cents an hour. So it gets pricey. I love how it's like cents per hour, but if we're like 4 times 24 times 31, we're like $300 right there. For an individual like me, that's a lot. If for my employer, a multi-billion-dollar company, it's not great to spend any amount of money that you don't need to spend. But yeah, it's great. See, $80.60 an hour. Now that's pricey. That becomes, yeah, if you pay as you go, $2. Wow. Okay. Anyway, yeah. So these are the ones you would want. Oh yeah, and you also have Linux, right? Okay. Okay. Whatever. That's what they meant. Solution 2. For Azure Cloud Services, configure each of your roles to use multiple instances. Roles to use multiple instances. I want to understand what that means. Azure Cloud Services. Is that a different things? What is that? Infinitely scalable cloud applications and APIs. I find that pricing is the best way to get an idea of what is happening. Okay. Whatever. Okay, virtual machines ensure that your VM architecture includes more than one VM, and that each VM is included in an availability set. Right, so if one VM goes down, another one can take its place. And we recommend using virtual machine scale sets for auto-scaling capabilities. Yep. So scale set is something where you can say, hey, I have between 1 and 50 virtual machine, and based on these rules, right? If the CPU gets to, I don't know, 50%, add another virtual machine to handle the load. And if the CPU gets below 25%, reduce the amount of virtual machine. Or you can do that with memory too, I think. I think those are the two basic ones you can use. All right, layer security defenses in an application to reduce the chance of successful attack. Implement security enhanced designs for your applications by using a built-in capabilities of Azure platform, such as NST, IP, allow lists, whitelisting, and all that stuff. Cool. All right, DDoS protection implementation. Azure DDoS protection combined with application, the best defense against DDoS. Is that an offering itself? I thought it was like a firewall thing. Okay. Let's see. Can I create DDoS? How does this work? That's great. I don't have $3,000 a month. That's $100 a day. YouTube fine. What am I missing now? Huh? We good? Come on. I'll make it work. Does that mean you're gonna charge me $3,000 like right now? You know what? This is terrifying. I do not have $3,000 to give Microsoft. And actually, I'm just gonna be like, let's cancel. I'm not gonna try it. This is too terrifying. If it was pay as you go, I would create it for you guys and show you what it is, but and how it works. But yeah. Okay, so basically what it looks like is you create your plan and then you say, hey, here's that. So that's the protection service. And then you're like, hey, here's the IPs that I have to protect, right? And it just protects them. So if you have a certain amount of IP, it's worth it. I think it allows you to not. All right, so there's basic It's automatically enabled as part of the Azure platform, right? So it's like, hey, I'm just going to put the bare minimum effort into figuring out if it's a DDoS. Then you have standard. That's the one where you have to pay. So you can tune it specifically to Azure Virtual Network resources. It's simple to enable. Application change protection policies are tuned through dedicated traffic monitoring machine. Monitoring and machine learning algorithms. All right, basically it's learning and it's looking at your public IP addresses and automatically adjusting to your traffic to recognize what a pattern is and anything that is out of the pattern, right? I don't know where it went. Yeah, anything that is out of the pattern, you're like, hey, this is not normal. We're going to block that, right? Okay. All right, so types of denial service attacks. Volumetric attacks, so it's basically to not flood the networks. That's when multiple people attack right at the same time. That's when you try. This one is when you target a specific port, and this one is when you attack the application layer, so the hosts themselves, right? To distribute the transmission of the data between hosts. HTTP protocol violation, SQL injection, cross-site scripting, and other layer 7. 7 is application attack. Okay, all right, firewall. Basically, a firewall is the same as a regular firewall. Prevents traffic from coming into where you want it to go. High availability, high scalability, Fqdn, filtering rules. Yeah, so you can. That's pretty cool. Network traffic filtering rule. That's the basic of source and destination IP port protocol. Qualified domain tags. So to allow well-known Azure Service Network traffic through your firewall. For example, say you want to allow Windows Update network traffic through your firewall, you create an application rule and include the Windows Update tag. Now network traffic from Windows Update can flow through your firewall. Okay, so that's application. Outbound source network, address translation support. All outbound virtual network traffic IP address are translated to the Azure Firewall public IP. You can identify and allow traffic originating from your virtual network to remote. So what this means is that basically I talk to you, and every time I talk to you, it looks like it's coming from my firewall. And so when you want to talk back to me, it's got to go back to my firewall. Okay. Inbound destination network, DNAT. Inbound network traffic to your firewall public IP address is translated and filtered to the private. Yeah, so that's now that you give a message to when an application gives a message to the firewall, website, whatever, then it will it will route the traffic accordingly. All right, and monitoring. Right, network address translation. Right, that's what it says. Yeah. You filter inbound traffic with the firewall, and the rule of the firewall is applied first. If a match is found, an implicit corresponding network rule to allow the traffic is added. You can override this behavior by explicitly adding a network rule collection with deny rules. Okay. Firewall rules to secure Azure storage. Azure Storage provides a layered security model which enables you to secure your storage accounts to a specific set of supported networks. When network rules are configured, only applications requesting data from over the specified set of network can access the storage account. All right, let's look at this. Right. Network, so you can say private endpoint or selected networks, right? What security? Why are you? Whatever. Grant access from a virtual network. You can configure storage accounts to allow access only from specific VNets. Yeah, that's what we just looked. Okay. Controlling outbound network access is important. L3, blah, blah, blah. Fully qualified domain name tag. Infrastructure qualified domain names. Track threat intelligence-based filtering. Rule processing logic. Service tag. Okay. All right, let's go through this quickly. Fqdn tag, so you can say, hey, these Fqdns, fully qualified domain names, so a machine on the network could join to domain. You can associate them with unknown Microsoft services. You can use Fqdn tag and application rules to allow the required outbound network traffic through the firewall, for example, Windows updates, infrastructure, domain names. They're allowed by default. These Fqdns are specified to the platform and can't be used for other purposes. The following services are included in the built-in rule collection: compute access to storage platform image repository, manage disk status storage access, and Azure diagnostics and logging. Okay, login metrics. You can monitor firewall logs, threat intelligence-based filtering. To alert and deny traffic from IP addresses that are malicious or known to be malicious. This is so boring. Service tag represent a group of IP address prefixes to help minimize complexity. For security rule correction, you cannot create your own service tag nor specify which IP addresses are included within a tag. Microsoft manages the IP address prefixes encompassed by the service tag and automatically updates the service tag as addresses change. Okay. Cool. All right. Remote work. You can have policies for the virtual desktop infrastructure, virtual desktop support, whatever. Forced tunneling. So basically it says, hey, forced tunneling, the idea is you just go through the VPN. All internet traffic goes through the VPN. The advantage is you can control a little bit more how your traffic flows, and you can make it flow through, for example, your firewall. Okay, all internet-bound traffic back to your on-premise location via set-to-site VPN tunnel for inspection and auditing, right? This is a critical security requirement for most enterprise IT policies. Without forced tunneling, internet-bound traffic from your VMs in Azure always traverses from the Azure network infrastructure directly to the internet, without the options to allow you to inspect or audit the traffic. Unauthorized internet access potentially leads to information disclosure and other types of security breaches. As stated earlier, Azure currently works with two deployment models: the Resource Manager deployment model and the Classic deployment model. The two models aren't completely compatible with each other. The following exercise goes through configuring tunneling for virtual networks that are created via the Resource Manager deployment model. Azure RM. Okay. So the front end subnet doesn't use force tunneling, and everything else use force tunneling. Okay, cool. Oh, so we're not really going through anything. We're just reading more and more and more. This is just... All right, user-defined rules. 1 second. All right. A user-defined routes is a custom route in Azure that overrides Azure's default system routes and adds routes to a subnet's route table. Right. In Azure, you create a route table and then associate the routes table with 0 or more virtual network subnets. Each subnet can have 0 or 1 route table associated with it. If you create a route table and associate it to a subnet, Azure either combines its routes with the default routes that Azure adds to a subnet or overrides those default routes. In this diagram, UDR are used to direct traffic from the gateway subnet to and the web tier to the virtual network appliance NVA. All right, you have your own premise, and you're like, boop, go here, go here. Okay. I'm done. How much more do we have of this? This is just so much reading. 13. Wow. Hub and spoke. Try this exercise. Knowledge checks summary. Okay. To make an NVA highly available, deploy more than one NVA network virtual appliance. You can deploy an NVA to a perimeter network in many architectures. In the previous diagram, the NVA helps provide a secure network boundary by checking all inbound and outbound network traffic and then passing only the traffic that meets the network security rules. All right, that's this. This NVA. So, okay. However, the fact that all network traffic passes through the NVA means that the NVA is a single point of failure in the network, correct? If the NVA fails, no other path exists for the network traffic, and all the backend subnets will become unavailable. To make an NVA highly available, deploy more than one NVA into an availability set. Okay, just like a virtual machine, availability set means you have multiple, and if one fails, we're good. All right. The benefit of this architecture is that all NVAs are active, and if one fails, the load balancer directs traffic to the other NVA. Both NVAs route traffic to the internal load balancer, so if one NVA is active, traffic will continue to flow. The NVAs are required to terminate SSL traffic intended for the web tier VMs. These NVAs can't be extended to handle on-premise traffic because on-premise traffic requires other dedicated set of NVAs with their own network. UDRs and SSG help provide layer 3 and 4 security. 3 and 4 being, put it here, you can look at the OSI model. It's network and protocol. NVAs provide layer 7 application layer security. Cool. Hub and spoke technology. This is too early. This is too early. All right, reference architecture, hub and spoke. This reference architecture shows how to implement hub-and-spoke technology in Azure. The hub is a virtual network in Azure that acts as a central point of connectivity to your on-premise network. The spokes are virtual networks that peer with the hub and can be used to isolate workloads. Traffic flows between the on-premise data center and the hub through an express route or VPN gateway connection. All right, so basically they say, hey, we're gonna do firewall, you do your most basic stuff for like security. So here, this is the network security group. And you have multiple spoke networks. And then you have your hub network that has like Azure Bastion, which is used for connecting to virtual machines. You have the firewall, you have the VPN gateway, and your VPN gateway connects to your on-premise network. Okay, a typical use for this architecture, and before I go and read this, the reason for this is the idea is you can then make sure that everything is isolated as needed. So like resources can be grouped together and do their thing together without talking to anyone else that they don't have to talk to. And then you have this hub part that just controls everything else. So if you want to talk from this spoke network to this spoke network, what happens is you're like, I'm going to redirect this traffic to this hub network, and this hub network is going to pass it back to this network. And in doing that, it's going to go through the firewall, it's going to go through the gateway and whatever you have, NVA that we just saw earlier, and make sure that the traffic is healthy. All right, typical use cases for this architecture include workloads deployed in different environments such as development, testing, production that require shared services such as DNS, IDS, NTP, and ADDS, domain name services. I don't know what IDS, I don't know what NTP is. Directory domain services. Shared services are in place in the hub virtual network while each environment is deployed to a spoke to maintain isolation. Right, so shared services are in the hub. Everything else is in the spoke. So it allows you to share services easily as opposed to having to deploy them under each spoke network. Workloads that do not require connectivity to each other but require access to shared services. Like we said, you don't need to talk to each other, but here's the shared services you all need access to, such as identity, for example, is one. So AD domain services. Enterprise that requires central control over security aspects, such as firewall in the hub as a DMZ, and segregated management for the workloads in each spoke. My brain is not... What is DMZ? What is DMZ? What does DMZ stand for? Data Management Zone? Is that what we're talking about, DMZ? Oh, I should have... I think that's what it is, Data Management Zone. I really want to know what DMZ stands for. Let's see. I'm very upset that everybody says DMZ, but nobody says what DMZ is. Sometimes just knowing the acronym helps. Sure. Okay. What is a DMZ network? In computer security, a DMZ network sometimes refers to a demilitarized zone. That's what it means, demilitarized zone. Okay, functions as a sub-network containing an organization's exposed outward-facing services. It acts as the exposed point to an untrusted networks, commonly the internet. The goal of the DMZ is to add an extra layer of security to an organization's local area network. A protected and monitored network node that faces outside the internet network can access what is exposed in the DMZ, while the rest of the organization's network is safe behind a firewall. Okay. See, sometimes you need to. That's my problem with everything that uses acronyms, is that it doesn't really explain what it is DMZ. Right. So basically, hub and spoke, you would do this. You'd be like, hey, this network is open to the internet, and if these resources want to talk to anything else in the network, they have to go through this hub network that will look at its traffic, inspect it, and make sure that nothing bad is coming into the on-premise network. And even if it goes to this spoke network, which may not be exposed to the internet. Okay. All right, the architecture consists of the following components. On-premise network, a VPN device to connect the networks, right? A device or service that provides external connectivity to the on-premise network. The VPN device may be a hardware device or a software solution such as routing and remote access services. So in Windows Server 2012, 4 days of supported, blah, blah, blah. So it's site-to-site VPN gateway connection. A virtual network gateway or express route gateway. The virtual network gateway enables a virtual network to connect to the VPN device or express route circuit used for connectivity with your on-premise network. For more information, see Connect an on-premise network to Microsoft Azure Virtual Network. Hub Virtual Network, that's that virtual network right here. And where you host everything, you have a gateway subnet where you put all your network gateways. You have a spoke virtual network. So these are these. And virtual network peering, which is the connection between two Azure virtual networks. Try this exercise. VNet peering. Okay. Use RGB to connect. Okay. Put a virtual machine, create two virtual machines, review the IP addresses, make note of the private IP addresses based on the standard virtual networks, two virtual network, test the virtual machine connection. So, yeah. Yeah, this is depleted without errors. Okay. All right. Let's do this. So we're creating virtual machines. multi-standard. We're going to do disk. What's the price of this one? Yeah, I think we're fine. Disk. Sure, premium SSD. Networking. We're gonna have a public IP address. Let's do. Yeah, I love it. It's like, oh, it's gonna take 10 minutes, but it's like, all right, you still have to configure everything. I'm sorry, guys. I do not have time for this. If you make it here, if you make it to this point in the stream, and you're like, Carolyn, please do this for me, drop a comment below. Tell me you want me to do this, and I will go through it. I just don't have the mental energy right now to do this. I will maybe write some code to do it for me later, so this way we can have like everything deployed. I'll put it in GitHub so you can just easily create all this. Yeah, this is a pain. All right, now let's check. Which of the following features of Azure networking enables the redirect of internet traffic back to the company's on-premise server for packet inspection? I'm going to say traffic manager. User-defined routes. Yeah, well, when configuring Azure Firewall, the organization needs to allow Windows updates to the network through the firewall. Allows Windows Update network traffic through the firewall. Which of the following should be configured? So destination inbound rules. Yeah, maybe. A network address translation rules. No, because you're basically saying it's just like, hey, I'm going to redirect these requests to this machine, right? So that's not really that. Application rule, yes, because you're saying I'm going to allow the application Windows update through my network. An organization would like to limit outbound internet traffic from a subnet. Which product should be installed and configured? So limit outbound traffic from a subnet. Web application firewall, Azure Firewall, load balancer. I would say just a basic firewall, right? Web application firewall is for Azure web apps. Then I am completely wrong. Provide for web apps. Yeah. Do we have some sort of like network or whatever? Yeah, it's for web apps. So I would say not web application. A load balancer just redirects traffic. It's basically dumb, right? It says, hey, I'm gonna just balance the traffic, right? But it doesn't say You can't just say, I'm going to deny this traffic, right? You have to have some sort of firewall. An organization has a web application and is concerned about attacks that flood the network layer with a substantial amount of seemingly legitimate traffic. How can this type of attack be blocked? Web application firewall. Firewall doesn't really do that. Just blocks. Azure Firewall, same thing, just blocks. But here we're looking at denial of service, right? Let's check the answers. I'm assuming the first one is wrong. Oh, hey, no, the first one is not wrong. All right, can I unlock the achievement? Boom. All right, implement hybrid identity. I think this is the next one. I think this is the next one we're going to do. So that's this live stream. I'm going to go back. We have another one coming up at 11, I think. So I'll see you then. Have a good day. Bye.